Okay, great transition to the next medical topic. Today I'm Tobias Blaufuß. I'm working for Siemens Healthineers, especially in the CT department, and we try to tame the complexity there with the help of CT scanners. And this project is now 8 years old, and we give an update from time to time in meetups like that. But I'm aware of the situation that some people here might not know about this topic, and it's now 3 years ago where we gave the last update. So I tried to find a good sweet spot there to give an update about it. First of all, let's clarify what we are talking about actually. To the top left, you can see the CT scanner with the table where the patient lays down, and this donut-looking device we call gantry. And if you remove the hood of the gantry, you could see some hardware that looks like that with the X-ray tube on the top. It emits X-rays through this collimator device, and this is necessary to focus the X-ray beam and split it up into slices. And then when they travel through the body of the patient and they land on this data measurement system, and there we receive a signal where we reconstruct images like this heart here. This whole scan procedure can be static, like in case A, where you just create 2D slices of the body, or it can rotate so that you also can create a volume image of the piece you're actually scanning. Now let's a little bit deeper into the software subsystems. On the gantry, there is the embedded software to control the hardware components. Attached to this gantry, there is the image reconstruction system, where the only purpose of that is to reconstruct images based on raw data, and it's a high-performance machine with this only purpose. And then we have this acquisition workplace, which is our our domain working space here. And this is there to parameterize the scan itself. So how should the data be acquired of the patient, and how should it be also reconstructed after it is acquired? It was required. Our motivation and vision for this topic is also familiar because of the previous talk. We have multiple domain experts like physicists, mathematicians, system engineers, and they define specifications in form of Word documents, Excel sheets, or some other data type, basically. And then they hand it over the wall to software developers, and they have to interpret the specification that is 40 pages long and even longer. And then you have to basically also have a physics degree next to your computer science degree. But so three problems that could occur here are, first of all, the domain experts could make mistakes. We don't recognize them, and then we implement it in the model, and then later in the development cycle, we get the feedback, hey, something is wrong there. The second problem could be we misinterpret some rule that was written by a physicist, and same problem occurs here in the end of the development cycle. And the third problem could be we understand us completely, domain experts and software developers, but then at some point in time, a specification gets updated, and these specifications are interconnected with each other. So an update of a specification has to be propagated to all references, and they only reference them via text. So an update there could be missed. It could be overlooked by us or the domain experts. and the resulting artifacts in the software are not up to date. So our main goal here was to, basically get us out of this interpretation loop and do not work with these Word or Excel specifications directly. The domain experts should just work with our model as a single source of truth. They have different views on it, but we can ensure that each specification that can be created on demand is consistent in itself, and one update influences the other automatically. So this was is still our initial vision for this domain. And as I told you already, there are multiple stakeholders that are involved in this development, and they all speak a different language when they talk about the system itself. So they say 10 words for exactly one thing, and I always have to ask, hey, do you mean this and that? And then they said, yes, it's exactly this. So there is not one DSL to rule them all, but there are several ones to specify it here. And we specifically are focusing currently on physicists mainly, and the system engineering and R&D department with software developers, and hardware is in planning, but mainly physicists for now. And first of all, I want to explain the domain before we come to our short demo. The core of our domain is represented by something that is called the mode paper. A mode itself is just a combination of parameters that are necessary for a clinical scan. For example, if you want to scan a heart, a mode defines which parameters make sense to get a good image or a good raw data that is created, and everything is inside this mode paper. So the why we chose this mode paper, it has many readers, it changes on a regular basis, and many outputs depend on it. So it made sense to tackle this one first. And the output here is just the word specification, and also it is checked with checking rules. Basic stuff. And then when we have this domain ready, defined by physicists, we can attach other subdomains to it. For example, as I said, the mode paper defines clinically and technically possible parameters of our scanners, and this protocol model defines these specification in code. So it made sense to include this one obviously, and we generate system configuration files and also specifications here, because why do we always have these Word documents and so on? It has to be documented what we do on a long-term basis, because otherwise we can't release a scanner in certain areas. For example, the FDA in America, they require us to do this kind of documentation, so we can't cut out Word or these specifications completely. And this continues. There's also the service software. So, for example, if a hardware device has to be replaced in a hospital, then the service technician goes to the hospital, replaces this device, and then certain calibrations have to be done for that, so that the scanner corrects some errors that might be in some differences to the previous hardware that was built in the system. And also we have to make sure that our daily checkups of a scanner, and in this case we also make sure that these daily checkups always include what is technically possible with the system. So this made also sense. And the last part, this image reconstruction system, there is no connection to the outside world for this IRS. So it is necessary that we ensure that all data that we actually expect via our parameterization is really on the system. So we have also a domain in place that where you can define what has to be deployed to this IRS. Because if something is missing there, it might not be possible to reconstruct data. So you can imagine you scan the patient, you scanned in and exposed him to X-ray beams, and then you can't use this data. It's really a problem here. Yeah, and then we, I guess, can directly get to the small demo. Obviously, I cannot show everything here because it's a really big one, but just the first one here. I have to do something. Wait a second. Oh, good. First step, second step. Okay. So as you can see, we have two solutions, the platform and the product one, because we follow a product line approach where we start with the scanner platform. A platform can have multiple scanner families, and then inside this family, we have the final product. So if we open this up in platform, we have platform A and B, and in scanner product, families are indicated by these three characters, and products with these suffixes. And the idea here is to define everything that should be possible inside a platform from a technical standpoint on the top level. And then you can restrict your definitions based on what is actually possible on the final system. If we, for example, start here that a system contains certain parameters here, and if you have the base component of a parameter, it is a name, it has a type, where is it used, also a physical quantity. Like you can define any unit that you want here in this case. So with a base unit and millisecond and also some special ones, you can also combine these units to have something like acceleration or speed in this case. Default value and description. But the thing that's missing here is obviously a parameter can also have values. And then we have this this dedicated value range catalog, so we call it, where you can refer to parameters and then define value ranges for it. For example, there could be discrete values here in form of numbers and the unit here at the end. And or they can also be just strings or a range where we have something here like that, 1 to 50 with an increment, like that. And you also can combine them. So if you have this parameter at the bottom, it's composed out of two parameters, this number of data sets and resolution of data. So when you create a new one here, you have this combined literal, and there the first one is only this resolution of data sets, and the second one would be this one. And as said, you can restrict these ones. Here we are at the highest hierarchy, so there is nothing to restrict here. But as we continue downwards in our hierarchy here, we see, for example, in the bottom one, that we restricted some parameters here. For example, this number of data set, we said, okay, on our lowest level, 2 and 4 are not possible for some reason. So this means indirectly, we also restrict this mode here at the bottom, because one hierarchy up, it was possible to define something like L2, H2, but if we remove 2 and 4, those are not possible and have to be removed. Sometimes there are also, so 20 possible values here, for example, and then you obviously can type in this value. And as you see, 8 is not possible according to our restriction hierarchy. So you can also type it in manually, or you can also just open up this completion menu where it's colored what is actually possible if you want to define something new. Okay, you can also just deactivate it, but as you see, this would have some other implications here. yeah, so it's hard to do it with one hand. Okay, saved it. Saved. Okay, so and then when we have our final set of parameters, we can combine them in the form of rules. For example, it can be a little bit more fancy in form of formulas, where you also can refer to numeric parameters here, or in form of tables with checkboxes, and you can restrict it. For example, for a spiral skin, you can restrict this specific parameter to this value range here. If you type in something that's not possible according to our our restriction on this level, you get notified, obviously. Yeah, and so on. But these are just examples. Those are not the important ones. Mostly they serve a documentative purpose. Some of them can be used in subsequent processing, but mainly we have these tabular ones where we define these modes that I mentioned earlier. Here you can say, okay, this mode has these parameters set. It's a regular clinical case, or this one, clinical usage, could be cardio or a head mode, for example. And we then can define other atomic rules to add additional parameter values to not define this big table or this big mode combination at once. And then we also have this, you can export it, because I said Word is necessary in our domain. So we can glue these inputs together into this specification node here. You have some metadata and a document history. And here you can include your rules. If you remove something here that something like that, it tells us the user missed something here that was expected actually. And here we remove this fancy rules. It was expected that it be there. So so we inform our users about such things. And then you can just invoke this generator here. The first time it takes a bit because it like 5 seconds or something like this, because it loads these binaries in the background. The second time it is quicker. And just a quick look here. But and the main aspect here is that we now we have the core, and then we attach multiple other domains to our system here. But I can't go into detail here. The thing is that we have in place, we implemented a framework where we can map each parameter and value to a specific name that is used in this domain, because I said they speak different languages, so we always have to map these values to the expected output. Unfortunately, I can't show you more due to time constraints, but I wanted to show you the last things here, which would be we have customized RCPs where we have views based on the stakeholder, and also custom tools, menu entries, and checking rules, because it is only necessary to execute checking rules that a user also can solve. It doesn't make sense that we should solve problems that only physicists can solve, for example. We also have an update checker in place that is a little bit more obvious, because for our non-technical users, this tool is not always so easy to grasp on. And we can update our plugins on the spot here. If we do an update, we can disable and enable our generators in our menu, because this saves us obviously some time here. And Git action wrappers are something like when you combine handy Git actions, like if you want to push something, it does a commit prior or checks if there are still outstanding changes, because as I said, we have non-technical users to our domain here. And lastly, RCI build chain, just a quick rundown. we can split it up into production model and our development process here, our own. But here is the production model process. As soon as we release RCPs and we push our stakeholders push something to our domain, to our repository, a CI pipeline checks if the model is still valid, then it generates the artifacts, and after the artifacts are generated, a system integration pipeline executes integration tests automatically for each of our scanner models. So like above 10 scanner models that we have in each execution, there takes up to 4 hours for each of them. So this is really helpful. And as soon as this one is green, we know we can check in those files in our system and nothing will break. And the biggest achievement here is this automation integration that we have currently. And in the future, we want to also automatically check in those files that there is this last step of ours is not necessary anymore, that we have to check them in manually. Yeah, and the last topic here is our plugin release server. I don't know if someone also uses this, but it's really helpful to just update plugins because we upload our binaries to this plugin release server, and our RCPs monitor if there are any changes, a new version is out, and then we update these the local plugins. But there is a lot of room to automate this because it's rather new for us. And also this web RCP topic is very interesting because this might help us also with the automatic release of RCPs, because if the underlying MPS version changes, this migration is almost always requires a reinstall of the RCP, always. And obviously we have a lot of stuff to do, so a lot of models to include here. And last, this is just our 2 major language design usability challenges. So if you have editors for non-technical users that transitioned from Word or Excel, they have multiple possibilities to execute a model operation. In form of an intention and a button, an editor context, and so on, because they have different frequencies, usage frequencies. And if you come back to this tool once per milestone, for example, you forget what are intentions. And then they just do a right click, and they also have this menu available for them. So this requires a lot of maintenance work, obviously. Also overriding and disabling every basic operation here, like copy, paste, cut, and so on, because if this was done per accident, you'd cut something out, and then your model is, if you got to disable this one or override it, they probably call us and say, oh, something is wrong, I don't know. And also these performance root nodes, you can split them up, yes, but it blows up this project view a lot, and then maybe we just need something that summarizes it again for the stakeholder. Even then, if you just have one big table, it's still a problem because you can't split up this table. So and if you have a table, for example, if you have 20% of your screen is filled, is visible, the rest of the 90% is not visible, you make one change and everything is reloaded, but the user is not interested in the other 90%. So it's something like lazy loading just came up yesterday to my mind. So that's it, basically. Test.
You're using MPS generators for these documents, or?
No, we are using docx4j. So Java library for generating OpenOffice XML. Yeah.
And okay, slightly the question still applies. How do you test these generators?
That's a good question. So we that's one challenge. So we have tests in place that make sure that a model is generatable and doesn't break while generation. But it's hard to to test if the content that you want to see in this document is really there. So yeah, that's currently one challenge that we have to overcome, because there are some with LaTeX it would be a little bit easier, because in Word you have a lot of automatically generated IDs and stylings. That's a current problem. Yeah.
I have a small question about what I saw in the editor. What is the little lock doing functionality-wise?
Again, please.
So in the editor you were showing,
Yeah.
I saw there were a field, and next to that field there were a little lock icon. Remember?
Yeah.
What is that doing?
You mean this here, or?
No, a lock, like a lock, like locking.
Yeah, okay. This is something domain specific, because parameters can have semantics and some of them don't. And semantics, you can react to them in your code. Yeah. If a specific parameter is set, we have to react on certain values of this parameter, for example. There is an if in the code, but it could also, we can reuse these semantics also in other domains here. I mean, I don't know when I find it. But there are some ifs there, yeah, in some cases. Yes. So what I didn't tell, there could also be another hierarchy above these platforms, because sometimes, or in our case, parameters should be known to platform A and platform B, but values and default values could differ between those. And then on the top level, you can define rules based on semantics. Yeah, but there are ifs in the code area for this. Yeah, exactly. Yeah, if a parameter has a semantic, it has to have exactly this name, and it can't be changed. Yeah.
Okay, we actually run out of time. So thank you, Tobias.